Welcome, Jake Pearman. We're so grateful that you had spent some time with us today, all the way from FAU, Florida Atlantic University. So tell us a little bit about how you came to be involved in space and how FAU is starting to build a program there.
Sure. Yeah. So first off, thanks for having me, both of you. I really appreciate the opportunity. How I got in space is, well, I wanted to build a CubeSat since I started the university, and I realized that the university didn't have a program. And so myself and another colleague of mine decided that we would be the ones to pioneer that at the university. And it just so happened that uh, at the time, the College of Engineering was just starting up their aerospace program, an aerospace certificate course. And it just all happened where it lined up to where we were able to start a club that started to build CubeSats and aerospace systems. We're part of AIAA now, and we're partnered now with the aerospace branch of the university. And so the coming together of both of those is really what kind of thrust me right into the middle of it. And that's where we are today.
Now, it sounds like you were at the right place at the right time. So, where something you'd always wanted to do was also something that was emerging. I also went to FAU, and it's really rewarding to see that they're kind of getting involved with this aerospace sector. It wasn't really always that FAU has been competitive in that area. So, I think this is a really good sign. What are some of the things that you notice as a student there that make it maybe challenging as you are just kind of going into the kind of CubeSat realm? Any challenges that your team has seen?
Yeah. First is just the lack of exposure in this category in aerospace overall. Typically, the university has focused more on vehicles and underwater vehicles, being that we have an ocean engineering campus called CTech, and we're predominantly ocean and vehicle-based engineering. So as we dive into the aerospace sector, it's been a learning curve to understand all the systems required and how they're different. And so getting everybody trained up and researching in different fields and what they've been used to for many years. That's both on the faculty and on the student side. On the student side, it's been particularly challenging because we've always applied the STEM concepts we're learning to land and underwater vehicles. And so applying it to an aerospace field is something that's brand new. Flight dynamics, turbo machinery, aerodynamics, these are all new concepts to a lot of the students. And so being able to apply things that we're learning when the last courses that were offered in this category were 2012 and prior. So we're definitely seeing a lot of learning curves in terms of application, but that's the challenge with engineering. So we've been chugging forward.
I think one of the advantages that your campus could really leverage, when I went to NC State, we had a lot of industry collaboration, and there were buildings on campus where basically the companies were setting up shop, and there was a lot of good exchange between the students and the companies, which led to kids being employed and getting really good industry relevant experience. Palm Beach County has Aerojet Rocketdyne, Sikorsky, Pratt and Whitney. I mean, it goes on and on. There's a lot of Belkin. There's a lot of great engineering that we could, that FAU could collaborate with to really build, some students that are what I like to call very employable and real savvy with industry. So let's talk a little bit about, I know you mentioned your aerospace technician certificate and your mechanical engineering program. Were your classes in your undergrad primarily your aero side? Were you dealing with fluids, say submarines and aircraft and whatnot? Or did you do some of the satellites as well? Because I'm curious to know if you, it's just like an internal motivation to get this CubeSat off the ground, or were you taking classes that helped you prepare?
No, the short answer, I was not taking any classes. There weren't many classes that applied at the core engineering curriculum to the space sector. We have fluids, applied thermal fluids, which goes over HVAC systems. We had some thermodynamics involved there. Strength of materials, you're covering structures and statics and dynamics. All of it separate doesn't really culminate into something aerospace or particularly CubeSat related. The predominance is, civil engineering and like I mentioned before, the vehicles, maybe some underwater vehicles. But the intrinsic motivation really came from there was an opening and we're on the Space Coast, and all the opportunities that are available just seem like an untapped resource. So the intrinsic motivation wasn't just me, though. There were a few of us that saw this opportunity and came together over the course of a year. And then that's when it started to become what it is today.
Yeah.
Did you begin pre-COVID, or was it sort of like during the COVID times that you really got motivated?
Pre-COVID, we started talking about this July of 2019. And then, so I was in college for a year at that point, and me and another colleague of mine, who's not in it anymore, but he and I decided we were going to pioneer a club that would start this off. So 2019 of July, we got established in September 2019, and then May of 2020 is when we really kicked off. We had about 85 total members contributing to the project, which is great for a first start after a few months of just from idea all the way to having a base of 80 people working on the project, which is great. And then we worked through COVID. And then once 2021 hit, things started to phase out as classes started to transition back in person, and all the dynamics associated with that caused some things to fizzle out a little bit. So then now, fast forward to where we are now, fall of 20 or summer of 22 is when this project got picked back up. And now it's in full swing. I would say 5 times larger and more successful with more faculty backing than what it ever was back then.
That's phenomenal. I mean, are you able to share what you're proposing to work on? Or have you started developing your CubeSat, or are you in the process of submitting that to the CubeSat launch initiative? Or
Yeah, so what we're building right now is a 6U CubeSat. It's with Kennedy Space Center and the Florida Space Grant Consortium. And what we're doing is trying to tackle one of NASA's research gaps on plant radiation, particularly chronic low-dose radiation exposure on plants. And there's a biology professor on campus who we met who is able to genetically modify plants so that they're radiation resistant. And so this CubeSat is a prototype that's going to go up on a high-altitude balloon that will gather radiation data from a Geiger counter as we monitor two plants, one that is radiation resistant and one that's not. And it's going to be exposed to a low dose radiation of about 60 to 90 minutes, which is pretty similar to one orbit around Earth. And it's just a demonstration of knowledge. The future plans in 2025, 6, 7 is that this will become a full scale model, flight ready with graduate students, undergraduate students, faculty, and we'll actually be able to send this with the CubeSat launch initiative. We want FAU to be a biological based platform for CubeSats and provide that service for NASA and particularly Kennedy Space Center conduct experiments.
yeah,
And
I
what
think
we're
that'll
trying
be
to tackle with, I'm sorry, I didn't mean to interrupt. Go ahead.
No, I interrupted you. I was just, that's a good collaboration, like between everybody like that. And I think it's
Yeah.
like it's a pretty good idea to actually do it first with the high altitude balloon, because then you have some kind of data to work with, right? So no, go on with what you're saying.
Right. Yeah. And what we're trying to tackle is NASA's Artemis mission, which is going to the moon and Mars, has what's called a lunar outpost, which is called Gateway. And Gateway is going to orbit the moon, and it's going to be a hub for astronauts to stop at prior to, let's say, they're going to descend to the moon or prior to going on to a deep space mission. One of the things that's being conversed about is how do we have plants fully autonomously grow without any astronaut presence? Astronaut presence provides carbon dioxide, and it also provides radiation protectant. But to protect an outpost, like the radiation walls, is expensive and heavy. It requires a lot of work to get out there to the moon. So being able to provide an environment where you don't need to worry about radiation shielding and the plants can continue to grow is something that we don't know about yet. And so by making this stepping stone in, we're providing a low-cost option where NASA can send off a lot of CubeSats with a lot of different types of plants. We have what's called an environment control system, which manages temperature, lighting. It manages the rate of photography that you want to get, day-night cycles, many other factors, including CO2 emission. And that way, we can send out lots of different plants into multiple different orbits. They'll deorbit by themselves, and the data will be autonomously sent down to the ground station, so we can gather data on what types of plants work and what types of plants don't work when exposed to radiation.
Well, that's great.
Yeah, that's outstanding.
Yeah.
Yeah, you and I have spoken before, and by the way, Jake was one of our presenters at our first small set education conference. So hopefully, we're already talking. We want FAU to present there again. I feel like our conference is a good vehicle for you to keep updating us on the status of your project. For instance, next year we should get it would be great to get the data, see a presentation about your HAB mission. But I do know for a fact that you got a unique opportunity out in Pasadena. Why don't you share a little bit about that?
Yeah, sure. So one of the features of our satellite is the flight software that we're using on it, which is JPL's FPrime software. And as I've been informed, Michael Starch, who is a previous person on this podcast, is part of the leaders or the leadership team of the FPrime software. And so I got to meet Michael Starch. I reached out to the project coordinator, who's Jeff Levinson. And we went out. I got invited out. It was only 20 university students invited nationwide to go, including students from University of Hawaii and a couple other universities nearby in Southern California. So it was pretty interesting to go back to California and to get to meet the team there. And it's really cool. You get to sit in the back, and in front of you are what they call JPLers, or people that work at JPL. And for 3 days, we went through a flight software course, and it was pretty intense. It was, we started at about 8 a.m. and we went all the way till the early afternoon with a small lunch break, and we were in the course the entire time. But it's a great software. It's very easy to learn and understand and apply. And yeah, it was a pretty cool opportunity.
Right. For our rookies, or those of us that don't code a lot, is it a language similar to something we would recognize like Python or C or Java, something like that?
Yeah, so the surface language with FPrime is FPrime specific. They have a language that's associated with the program. However, there's a wealth of resources available for you to understand that surface language. But behind it is C++. And so for those that know C++, it is C++ all the way.
Very cool. With its own syntax laid on top.
Correct. Yeah, and I will say that I've been able to understand it, and I'm a mechanical engineer. So my coding background isn't extensive, but I was able to attend and pick up, I would say, probably 80 to 85% of the information. And that last percent is where the community comes in, the FPrime community on GitHub, and also the personnel at the university who know C++, who've been able to dive in with me and give me some quick answers that we need as a team.
Speaking of mechanical engineering, I come from a non-science background, right? And so when we interview people and I hear about all these different kinds of engineering jobs, I always thought you had to just be an aerospace engineering if you're doing something with space. For our listeners who might feel like me, can you explain a little bit about how what a mechanical engineer might do, and ultimately why that's not a bad option to go for if you want to be in aerospace? In fact, here it's actually better.
Yeah. So that's a great question. I remember when I was younger, it was, I want to be an astronaut, so I'm going to go, astronautical engineering, and that's what I'm going to do. But as I've come to realize over the years that sometimes versatility is what's important, and putting all your eggs in one basket might not be the best thing for you to do. So, as a mechanical engineer, there are many different options that you can pursue. Like I said before, you can go HVAC and fluid systems. You can go into being a mechanical engineer on an aerospace system, as we're doing right now at the university level. So the diverse range of opportunities that you can pursue as a mechanical engineer, they apply to many different industries. And you can take a lot of the concepts that are in vehicles and apply it to aerospace systems, because screws don't change. Structural analysis doesn't change. The component that you're testing might change, and the factors of safety and everything else might change, but it's still the same process, and that's engineering. So, for those that are pursuing which degree they want to get, or trying to figure out which one is the best, I would say go for a more general degree and keep your options open, because you can always do what's called cross-training. You can switch from one department to the other and go from vehicles to underwater vehicles, or underwater vehicles to airplanes, or airplanes into space. It's all there for you. What matters is the effort you put in and the job you're doing right now.
Right. I would say in fact, you get a lot of creativity when you cross-train, or you pull people from other disciplines. Just for instance, you as a mechanical engineer, there's a lot of similarities between cars, rockets, rovers, spacecraft. They all have some kind of propulsion system. They all have some computers in them. They all have structures. So there's a lot of common subsystems, that might be specific to a type of vehicle, but they share basically a lot of the same subsystems.
Right. And I'd add to that, as a real life example, we have a team member on our CubeSat team right now, and some of the ideas he's presented, he's taken directly from his experience as a car mechanic, not even as a mechanical engineer, just as a mechanic. And some of the concepts that he's gathered from there, they almost fit perfectly into our design that we have, and we weren't even taken into consideration using any sort of vehicle engineering. So yeah, definitely, there's definitely some advantages when you take people with different types of experiences and bring them together.
Right.
You want me to take? Okay. So I noticed too that you are in the Air Force, and that after you graduate, you have plans to kind of go there full time. How are your interests in the Air Force connected to what you're doing now, or are they completely separate?
Yes, ma'am. So yeah, I've been with ROTC at the Air Force at the University of Miami for 5 years now. I'm a super senior. it's been a great opportunity, and they were connected in some way. So as I've said before, don't put all your eggs in one basket. I had a few separate courses of action open for me in the Air Force. One was to be what the Air Force calls a developmental engineer. And so you go in as an engineer, using your degree, and you work with defense companies to build the latest and greatest wonder gear. That was an option that I had open for me. Another option that I was planning on pursuing was going to what the Air Force calls the test pilot school. It's out at Edwards Air Force Base, and you as a test pilot engineer learn to fly in experimental airplanes, like back in 2000, the X-35 or the F-22 before it came out. And as an engineer, you'd run flight tests on it and see how it performs. That was another option I had open. And then the third was pilot, and the fourth was special warfare. I pursued all of those and ended up getting pilot first before any of the other responses heard back. And so if that's the first one you hear back, that's the one you're going with. So yeah, they were pretty connected. But when I leave and my contract is up, when I'm done there, I am considering possibly transitioning over to a contracting company, defense contractor, and being a flight test engineer with them. So the idea is I want to keep using my engineering degree and give back, because we've always been a great space nation. I think that we now need to come back.
Yeah, that's really admirable. I mean, it seems as though from the very beginning, you've had an idea where you wanted to be, and you're, as you said, you're diversifying, you're playing a wide, playing field, so to speak, but at the same time, you seem to have been on a path that regardless of how you're getting there, you're getting there. I think that's a lot about that fortitude and sticking to something, and then being able to see how it connects into all those other realms. It's really impressive.
Right.
Congratulations on that.
Yeah. Let's just extend let's talk about the piloting, your pilot profession. We live in an era where we're making more and more autonomous vehicles. And can you speak to what you may have seen or learned about the role of the pilot in a plane versus an autonomous vehicle, or a pilot and a swarm of autonomous vehicles working in concert together?
Yeah,
and
sure.
We'll try to avoid any movie references.
Okay. All right. So I can tell you that for many years, the pilot will not leave the cockpit. I'll just give the straight up answer right there. There's many reasons for that. But in terms of the fighter mindset, when you're in the military, working as a military pilot, if you're not piloting that airplane, you're managing other airplanes. And that goes back to your swarm comment there. So a couple of years back, I believe it was 2018 or 19, they tested an F-16 that was flown autonomously from the ground with no pilot inside. They've also run simulations where it's an AI adversary versus a human pilot. And the AI adversary, I believe, either won 2 of the 3 or 3 of the 5, but it was a win for the AI. All of that is there. However, the systems that we've come up with, especially for the fighter world, like the F-22, is we have fighter managers that sit off the wings of these fighter jets that the pilot will deploy. And the best asset that you can have in a war conflict is the human. That's the best thing you can have. You can fight AI versus AI, but what matters is the human element. And they're the ones that can analyze and figure out the best course of action better than any computer that we've come up with thus far. And when it comes to air superiority, which is the key to air power, air dominance, and bombing superiority, you need humans there to do that. So I would say that for a while now, we might have autonomous subsystems where missiles can auto lock. As you know, there's the new fighter helmet where the pilot can just look back and lock on a target, and the missile will turn around and go hit it. So some systems might become more autonomous, but the human element will probably never go away. Well, maybe not never, but a very long time from now.
Yeah, I'll make a movie reference. Most of us that were at one time involved with the military or served, nobody ever wants a computer to make kill decisions, right? We don't want the computers to do that, because that's how we end up with Terminator.
Right.
There's even a modern day reference, like from a literary perspective, and they turn it into a movie too for kids. It's called Ender's Game, and it really is where they're training young kids to go to battle up against AI, but it really does come down to the human being able to strategize differently and to be able to change up in a situation.
Well, my last comment, and then we'll throw our last question at you, is I want to share with our audience that Jake did a really great job. For 2 days in a row, I got to bring students. First, I brought my classroom students to FAU for a tour and a workshop led by Jake. And then yesterday, I brought some of the CubeSat students, the younger CubeSat team. And I want to just say, I'll say to you, Jake, I really appreciate the level of detail that you shared when sharing about the campus, because you're a great ambassador. What's funny is this family was just walking around and just joined our little group and did the tour with us because he was doing a good job. So I really appreciate you investing in the younger generation. As you know, I think mentoring is incredibly important. Plus you're modeling, you're always showing those younger kids how the right way to do something. And often we show them the wrong way to do something, but you're doing a lot of the things well. So I want to thank you for that. We also want to wish you good success, especially on the CubeSat and your career. But our last question, which
I'm going to switch it up actually. So I know that I told you in the beginning but you kind of gave us some advice. I actually want to tie that advice a little bit more to our students who might be thinking about maybe going into the military as an option related to their STEM pursuits. And I know if that's, it might be a little bit too broad, but we oftentimes kind of get the same thing, like follow your passion and all that. But if a student might be leery about considering going into the military, what advice could you give our students to maybe rethink that? Why might it be a really great path for someone who is interested in a STEM career?
Yeah, so I'll just bar all of the typical recruiting things about how you get great pay and, health benefits and monetary stuff, because you can get that also in private companies. So just to come right out of the gate, that is not why I think you should join the military. And if that's a reason why you want to go do that for the money reasons, it's the wrong reason. For those that want to pursue STEM in the military, it's because you want to protect America. And that is something that not a lot of people have. And that is something that you should explore more if that is something you're pursuing. It's really for the higher purpose of defending a country and its values that you believe in. And the best way that you can do that right now, while also defeating America's enemies, is producing the best engineering things that you can, and to be the best engineer that you can be. The best person that you can be in navigation, the best person that you can be to developing hypersonic missiles. The best thing that you can be as an avionics engineer, as a mechanical engineer, as a developmental engineer, as a test engineer. Being the best person that you can be will help you and help the country defeat our adversaries. So if you want to be an engineer and you also don't like America's enemies, that's why you should join engineering.
They need to put you on the marketing route. That's it's a really effective, very quick, explanation and sales pitch. I love it.
From a STEM standpoint, oftentimes, sadly, our nation won't invest in education to the extent it will defense, but there are so many spinoffs we get from defense research. This morning, I was working on a class, and GPS was a military constellation, but now we have Uber Eats because we have GPS. It's a $1 trillion impact on our economy from the GPS, which was originally a defense technology. So you're right. We can both protect the nation, and we're going to improve our economy and our quality of life. The better we are with advancing technology, because we certainly know other countries are investing a lot in things like AI and all of these advanced technologies.
I'm thinking about it like this. Like, it took me a while to wrap my head around the idea that aerospace was an industry in which anyone could find a passion. But it seems to me like the idea of serving in the military, if that's your calling, if that's your passion, you can find any industry related to that as well. So it's almost like the next realm up. That's pretty impressive.
There's definitely a continuum, right? You step off the bus at Parris Island at Marine Boot Camp, and that is one kind of life that you can have in the military. But then you go to the other end of the continuum, which I would call a Space Force engineer, right? And they're looking for masters and PhDs and the theoretical physicists, and their domain and their work experience and life experience, while no less valuable, is much, much different than I was an infantry officer. So that's one style. My daughter was a space officer. You're going to be a pilot. Those are, as she said, many different careers.
Right. And if I could add a couple comments to that. So I am, as you just mentioned there, I believe it's, don't quote me on the exact number, but it's about 10% of the US military are the ones that are actually firing the weapons at the enemy. The majority of the roles are support. They're the ones supporting the guys on the front lines. So, and that leads me to the next point, which is the reason I said the first point. the military industrial complex, that whole argument about, the military industrial complex is bad because they make money off wars and they fund wars. That is not what joining the military is about. It's about supporting the nation and the means that take you to that. So just wanted to add that out there, that it has nothing to do with the military industrial complex. It's something much different. And you should not look at the military through the lens of the defense companies. I want to go back though really quickly before we close out to a comment you said about mentoring and how that's important. I think another word that should be used when it comes to mentoring, because you hear that often, but what you don't hear often is the word continuity. And continuity, that comes from not just talking to people through a way that makes them idealize you as a leader, but it also comes from writing things down. And I think a lot of the times in at least my generation and the generations below me, and maybe a little bit older than me, we've lost the idea that writing things down is good and that it's a good thing. And I think a byproduct of that is that people just forgot how to write professionally. And then a byproduct of that is that people can't think professionally. And if they can't think professionally, they can't talk correctly. So I think part of mentoring is continuity. And it's mentoring people by giving them the information in a formalized manner that allows them to, what we call in military, copy, combine, and transform. Copy what's been done in the past, combine it with the new ideas, and transform the mission into something greater than it was before. I think that is a very applicable and tangible method that you can mentor people, even if you don't get the opportunity to know them personally and shake their hands. And so I would just encourage anybody, especially in the engineering world, and something that we're employing here as a specific example, interface control documents, understanding how to write grants, how to write proposals, how to articulate engineering designs and systems, how to make yourself stand out professionally, and writing all of that down and really understanding it and articulating it correctly won't just make you a better person, but it'll make everything that you do better because it's way more organized, and you'll go a lot further. So I just want to leave that piece of advice out there. Write things down and give it off to other people.
I agree. And as you and I have spoken, your time there is coming to an end at FAU. You got half a year left. Have you trained your replacement? Because that's very important that you leave when you always should, every student should always replace themselves on the team. I feel like, do you feel like you're ready to do that?
Well, I've taken on a lot. And so I've definitely put the burden on me to make sure that I hand off every gauntlet to the next person so that things don't fall through the cracks. Yes, there's a lot of people that I'm communicating with. And the key thing with that is that they need to be with you on the phone calls you make at the strategic level. They need to be understanding the things you're writing. They need to see the vision that you see months out rather than just seeing what the next meeting is for each week. Bringing those people in and keeping them in the loop in the conversation is how you train up the next people. And yeah, we have a few people that we're doing that because you always need some fail safes and backups. So the more people you have on a strategic team, the better. It's not just all on one person.
Right. And it's always hard finding someone as, committed as you clearly are, because it sounds like you might need 3 people to replace you,
Right.
Well, I thank you for the compliment, but I don't think I'm someone special. I think what matters is that someone buys into the mission. And I think if anyone buys into the mission as much as I've bought into it, any one person can do what I'm doing. It's just a matter that I don't think people have been exposed to such a level of commitment yet. And that might scare them. And that's totally understandable. And again, that comes back to mentoring. That comes back to demonstrating effective continuity and leading people in slowly over the next period of 6 months so that they feel confident and capable as an individual to lead.
Man, thank you so much for spending this time with us.
Yeah, of course.
Some really great insights. We hope to see you before you head off, and that we can continue.
Well, we're going to hopefully do a lot more projects this spring.
Yeah,
we're excited about your HAB mission.
Yes, of course. Yeah. So as you and I had spoken, the goal is that your students and mine launch the high altitude balloon together, which would be great. And you're in West Palm Beach, we're in Boca. And so we've already established a lot of relationships. So I'm really excited for us to be working together, even when I'm gone, working with the university and looking back and seeing everything that's going on and the opportunities that we can provide your students as a university. Really excited for that and to see what they do.
All right. Well, we look forward to hearing from you again soon. Thanks so much.
Of course. Yeah. Take care.